Good afternoon, everybody. I guess it's about time to get going. It's 25 past, so let's start. My name is Tommi Saxelin. I'm from Cisco, and I thought that I would start the presentation with presenting, I think, what is the best product by Cisco for this time frame. It is a mug. And taking into consideration that our dear friends and competitors, Bull, are offering champagne after this presentation, this is a very handy tool for that champagne reception. If you fill it up to here, it's a thermos mug, it will stay nice and cool and bubbly, and you can get your fair share of the champagne offered by our competitors, the Bull. And it has a nice Cisco logo in it. So the reason I'm presenting this is that I have two of these here, and I was planning on giving them out to those who ask the most difficult questions, or the most fun questions, or those who seem most thirsty at the end of the presentation. So anytime you want, just raise your hand. Anytime you feel like you need a mug, I'll throw it or bring it to you, and we can get going. So what I'm going to talk about today is the Cisco Unified Computing System, so Cisco Servers. The reason why I'm wearing green pants is because they are the greenest servers in the planet. Well, not really, but they are pretty green. But what we usually say in trade shows like this, events like this, is that they are best, or at least one of the best, platforms for virtualization and cloud computing. And I'd like to explain to you why, and then give you some brief overview of what the unified computing system is, what it looks like, and how it is built. But, it's a pretty bold claim, say that something is the best for something, but I'll try and explain. You can challenge me on that, and I'll come back with give you a mug, or tell you to go away and talk to Bull guys with their champagne and all of that. So, I'll start off with this guy. Does anyone know who he is? No. Good. All the more mugs for me. This guy is a Swiss person. His name is Edouard Bunion. And after graduating from the university in Zurich, he moved on to Silicon Valley to continue his studies in Stanford University. And in the late 90s, he was studying in Stanford and doing things about virtualization. And while at Stanford, he decided to start a company. So this guy, Ed Bunion, and four of his friends from college, they started a company called VMware. So Ed Bunion was one of the 5 founding members of VMware. This happened in 1998. When they started VMware, Ed was the technical guy. So he was the CTO, the chief architect, and the guy who did the coding. He programmed the first VMware hypervisor. And obviously, he had some sense in marketing, because VMware became the success it has been. So Ed, as the technical guy, wanted to build the best possible hypervisor, or the best possible virtualization software there is for an open platform, an open system. Of course, there had been virtualization solutions before on closed systems, mainframes and so forth, but he now wanted to do the best possible hypervisor for an open platform. So VMware was his child, and he worked there until 2004, when EMC bought the majority share of VMware. This is what many people know about Ed Bunion if they recognize him from the picture. Don't worry, I wouldn't recognize him from the picture. So the brains behind VMware at the very start. The interesting thing is what he did next, now that he had his fair share of the money that EMC had paid for VMware, he started another company, kind of in hiding, not totally in secret, but it wasn't very public. He started a company called Nuova Systems. The reason why the name of the company was Italian is that the two other founding members, gentlemen called Mario Mazzola and Luca Caffiero, were Italian. These guys, Mario and Luca, their background was in data center networking, or networking in general. They had founded a company called Crescendo Communications, which Cisco bought. That became the Cisco's Catalyst Ethernet switching product portfolio. Then they started a company called Andiamo Networks, which built a fiber channel switch called Cisco MDS nowadays. So Cisco bought Andiamo Networks. And now this was their third company, Nuova Systems, built up together with Ed Bunion. And here we are. Cisco bought Nuova Systems and their product. And the product that Nuova wanted to build was, now that it had written the best possible software for virtualization, it was the best possible hardware platform for virtualization. And that became known as the Cisco Unified Computing System. So Cisco bought the company in 2008, and that's when Ed Bunion became the CTO of Cisco's server business unit. So you can see that there is some backing behind our claim of us having the best possible virtualization platform. The same guy who built VMware with his friends and colleagues, of course, now built this server platform. Well, now he's no longer with us, with Cisco, that is. He is back at Stanford University finishing off his PhD studies because the business world took him away from the studies, and he's now finalizing his grades. So, we have a lot to thank to this guy, Mr. Bunion. So, what is it that he built, and how is it different from others? Let's have a look at the unified computing system. First of all, we can have a look at one of the elements where typically our competitors would say that, here you go, here you have the system. Well, in Cisco's case, the blade enclosure, the blade system chassis, is not the system. It is only a part of the system. This blade enclosure is, in our world, in Cisco Unified Computing System, the blade enclosure is just a stupid box providing power and cooling to the blades that are put into this enclosure. And because, excuse me, because it is a passive component and a dumb component, the lifetime of this box is designed for 2020 and beyond, because there is nothing active going on in there. And when we say that it is not the system in itself, we mean that you don't have to manage it. There's nothing to that box to manage. And actually, because of this architecture, in the Cisco solution, the blade servers and the rack mount servers are equal. You can use both building up the system, and you can do all sorts of things with them, which I'll explain later. So that's one big difference. Even though we show the chassis, the enclosure, that is not the system, it is only a part of the system. Well, how we connect this to the rest of the system, that's also a bit different from what others do. Typically, in other blade enclosures, other blade systems, you would put in switches, switch components, active networking elements that take part in the switching protocols of either the Ethernet networks or the fiber channel networks. Well, in the unified computing system, there are no switches in the enclosure. These fabric extenders are, again, you could say passive components in the sense that you don't have to manage them. They are actually part of the bigger system as well. they just provide the physical connectivity from the blade enclosure to the rest of the system, to the rest of the network. So they provide 10 gigabit Ethernet connectivity to the blades and so forth. Where we also are a bit different from other server vendors is that all networking within the system is actually Ethernet. So we don't do native fiber channel anywhere. And this enables us to be very flexible in how we take care of traffic. If you want to use SAN storage, fiber channel storage, you can do that by using FCOE, but the physical cabling is always 10 gigabit Ethernet. This architecture using these fabric extenders is actually a pretty compelling reason of choosing the unified computing system as a server platform. Because if you look at traditional blade environments where you might run a virtualization hypervisor on top, what you end up having is actually 3 layers of switching. If you have a rack in the data center, you will probably have a top-of-rack switching capability or functionality in that rack. Then you will need to have a second layer of networking in the blade enclosure itself, so you will have active switches in the blade enclosure. And then if you are running, for example, VMware, if you are doing virtualization, you will be running a virtual switch on top of the hypervisor. So in fact, 3 layers of networking. Then if you are doing it, the traditional way and connecting to a SAN, you will be running an Ethernet network separately and a fiber channel network separately. And you may have to add some more Ethernet for management or backups or whatever else. So quite easily you end up in a situation where you have, like in this example, 9 different networking elements to manage if you are, taking care of a virtual environment, for example. Well, by doing this fabric unification that we call it, putting everything on one protocol, one 10 gigabit Ethernet, we are actually taking all these different vertical columns, different protocols, and putting them all onto one 10 gigabit Ethernet connection. So that reduces the number of things you have to manage. But then the interesting architecture is the fabric extension, the fact that we are not using switches in the blade enclosures, and we are actually not using the virtual switch in the hypervisor. It means that we actually have only one layer of networking to manage, even to reach our virtual machines. And that architecture is called fabric extension, or that technology is called fabric extension, FEX. And it enables us to build a large computing platform with hundreds of servers, thousands of virtual machines with just one networking layer. So what you see in the top is the heart of the unified computing system, the fabric interconnect switch that creates all of the networking that is needed, and that takes care of some other functionality as well, which I'll mention briefly later on. The blade enclosures and the rack servers will be connected to fabric extenders. And as the name implies, they are not individual switches, they are extending the fabric created by that top-of-rack element. So in fact, you might have 20 enclosures in your data center, all connected to a single pair of fabric interconnects, and all of those 20 different fabric extenders will actually be logically part of that one element. So you won't have 20 elements to manage, you'll just take care of the one. And then if we go on to the virtual environment and want to take care of the virtual switch and the fact that in typical scenarios you have to manage the virtual switch, what we actually do is that in the server level, we allocate a virtual interface for all of our virtual machines. And this enables us to be able to get rid of the virtual switch, because in this case, if we actually give what the hypervisor sees as a physical interface to the network for each of the virtual machines we are running, we are actually connecting directly each of our virtual machines to the networking box at the top of our rack. So what that means, if you start scaling it up, we can actually put in 160 physical servers into this system. And all of the networking that you might want to manage is managed in that one networking element through one management. So 160 physical servers, and then if you start adding virtual machines on top of those physical servers, you might have, let's say, a small number, 10 virtual machines per server. You would have more than 1,000 virtual machines, 1,600 virtual machines, all managed through one networking element. Well, those boxes at the top are called fabric interconnects, and they provide very high bandwidth networking capability for this whole system. What they also do is they run the management. So we don't have a separate management server anywhere in the system, and no separate management software. Well, there is a piece of software running, but it's run on those switches. And that actually enables us to manage both the rack mount servers and the blade servers in a similar fashion. For example, a firmware upgrade, which typically means that you have to log into each blade enclosure separately, you have to log into each rack server separately. In the unified computing system, you log into one of those switches, tell the system that you now want to run a firmware upgrade job, and it will do it all for you. You won't have to touch anything. I'll show you a brief overview of what the management can do. All in all, when you put this together, put all the bits and pieces together, what you end up having is, this is starting to look more like a system. So instead of having just one blade enclosure as the system, we can actually have a rack and actually quite a few racks as part of the same system. The whole system will be connected with 10 gigabit Ethernet to the fabric interconnect switches, and those switches will then take care of all traffic, all protocols. They support fiber channel Ethernet, fiber channel over Ethernet, any storage protocol you might want to run, and you can take care of the networking all the way to the virtual machine layer by using this fabric extension architecture. Also, as mentioned, the manager is run on those switches at the top. So anything you might want to do in this system is managed there. Not only the firmware, not only the networking, but everything that has to do with the servers as well. And a very interesting method of deploying servers in this system is the notion of service profiles. What we mean by service profiles is that no matter what type of hardware we plug into the system, it doesn't have any identity in itself. So a server is just a piece of metal that is connected to the system. When we create a profile of a server type in the UCS manager, which physically is located in those top-of-rack switches, we can then move that profile to any piece of hardware we have in the system. So let's say we want to be able to create ESX hosts very rapidly. What we do is we create one template, and then we say, now we want 10 servers that look like that template. And the system will go multiply that template by 10, install 10 service profiles to blades or rack servers in the system. Well, that's one way that you can use the service profile. You can quickly create new machines, allocate new capacity. The other way is that you can use it as a sort of a poor man's high availability tool. If you, for example, are running an Oracle database, but you don't want to build a rack cluster, you don't want to have a cluster, you want to run a single instance database, but want to provide some high availability for it. So you preserve some spare capacity for it. In a traditional environment, if your Oracle database server broke down, you would have to do quite a lot of work to get it back up running again on another piece of hardware, because you might have to go into that piece of hardware, upgrade the firmware, make sure that the BIOS settings are right, maybe change the MAC address, or actually you might have to reinstall the whole license or relicense the whole software because it's now on a different piece of hardware, a different unique identifier on the server. So that would be the traditional way. In the UCS, what you would do is that if you're, let's say that you are running an Oracle system on a blade, if that blade breaks down and you have a spare rack server available, the system will move the profile of that Oracle system to the rack server that you had available. And while it is moving the service profile, it will actually take care of the firmware. It will make sure that the firmware and the BIOS settings are exactly as you defined in the profile. It will make sure that the MAC addresses, the worldwide port names of the host bus adapter, the unique identifier of the server, actually everything that the operating system sees from the hardware below will be exactly the same as it was on the blade that broke down. And now we move outside from the blade chassis to a rack server. And actually the Oracle on top would only notice that, well, I've gone down and I've booted back up again on the same piece of hardware, and nothing will change from the database's point of view. So that's another use of the service profile. You can use it for rapid deployment of new capacity or for high availability configurations. The servers themselves are nothing really special. The servers are servers. It's Intel-based platforms with memory ranging from 192 gigabytes to 768 gigabytes per server, from 1 to 4 CPUs and so forth. On the networking side of things, we can do very high bandwidth configurations. The maximum is 160 gigabits per second per server. So that's 60 and 10 gigabit connections per server. And that's what you can do on these blades. I would say that the typical use case is to choose the new Intel Sandy Bridge architecture server, use the dual 20 gigabit links, so 4 times 10, and run it like that. As I mentioned, the rack mount servers can also be connected to the same system. If you use the rack mount servers individually, just like they are here, not part of any bigger system, they act like any other individual rack mount servers. Nothing specific about that. We have a number of different options here, ranging from smaller memory configurations to larger ones. Actually, the biggest one can have 2 terabytes of memory, so it's a pretty big box. What's interesting with the rack mounts is that when you connect them to the fabric interconnect switches, they become a part of the bigger system, the unified computing system. And then they actually give up their management to the UCS manager that is run in the system. And you can then do all of the management tasks from the UCS manager. This is what the graphical user interface looks like. So this is where you would do all of the hardware management tasks in your unified computing system. So everything that has to do with the hardware itself, the firmware on the hardware, the LAN networking, the storage area networking, the service profiles are actually defined here as well. And as you can maybe see, there's a tab on the left that says VM. Well, that's the secret sauce behind how you provide the link between the virtual world and the physical world in the unified computing system. In the VM tab, you define a link between the UCS manager and your vCenter platform, and that will enable you to show from here any type of network configurations to the virtual world you might want. And that will actually make life a lot easier for the VMware administrator, because he will only see sensible network configurations. He won't have to figure out VLAN numbering or anything like that. And he won't have to take care of the virtual switch. The best part about this tool is that the cost is zero, so it is automatically built into the system. So whenever you get a UCS system with the Fabric interconnect switches, this is included. What it also provides on top of this graphical user interface is an XML-based advanced programming interface, API, where third parties can connect their tools. So companies like BMC, CA, IBM Tivoli, HP OpenView, Cloupia, all sorts of companies, Microsoft even with their System Center, they are using this API to take advantage of the fact that you can control everything through that API. And because it is the latest fashion, on both the Android market and Apple App Store, you can find an app that hooks up to that API, so you can do server management from your smartphone pretty easily. As I said, Cisco bought this company, Nuova Systems, set up by Ed Bunion in 2008, and the unified computing system launched in 2009, so about 3 years ago. And in those 3 years, it has actually become the second most sold x86-based blade platform in the United States, and it is, from a market share perspective, the third most popular blade server system in the world. So even though you may not have seen it that much in Lithuania yet, you will, because the numbers are there already in other parts of the world. You've been awfully quiet. Doesn't anyone want a mug? It seems that no. Don't worry. I'll be handing them out next to the bull booth later on. From my part, that is it. If you want to see how this actually works in action, how it looks physically, after the champagne break, after you've had your mug full of champagne, iPro, as one of our partners, will be demonstrating with live equipment in meeting room beta, I believe, the next one. So iPro's presentation that's on the agenda, called How We Build Cloud, is actually going to be around how you set up a UCS system, a real UCS system. And it is going to be a challenge for them, because they have 30 minutes to set up the whole system and put it together. So this was the slideware, and they'll be showing it in action, so I recommend to see that. Thanks for my part. Now it's time for champagne.